This is Unit 3, Moles and Stoichiometry, Lesson 8, Naming and Formula Writing for Binary Compounds with Multiple Charges. So how do we name and write formulas for binary compounds with multiple charges? By the end of this video, you will be able to identify binary compounds containing multiple charges by name using Roman numerals, and you will be able to construct chemical formulas for binary compounds containing multiple charges. Do now. So we have a problem. FeCl2 and FeCl3 are different compounds, but they seem to have the same name, iron chloride. How can we name them differently? FeCl2 is actually iron 2 chloride, and FeCl3 is actually iron 3 chloride. So what do the Roman numerals represent? So if you looked over here at the periodic table, hopefully you put together that iron 2 chloride is referring to the oxidation state of +2, and iron 3 chloride is referring to the oxidation state of +3. Transition metals and nonmetals are two groups of elements that have multiple oxidation states. The transition metals are found in the center of the periodic table, and the nonmetals are found to the right of the staircase, this black line right here. We'll learn more about those different features when we get to the unit of periodic table. What makes them unique now is they can have multiple charges or oxidation numbers. So you must show which charge you're using with Roman numerals. For example, when I write iron 2 oxide, that 2 Roman numerals referring to the +2 oxidation state of iron. So how do you determine the charge? So first you have to find the charge of the anion. This is the element listed last in the formula, and it will always be a negative charge. Set the whole thing equal to 0, since compounds are always neutral. Then solve for the charge of the cation. So iron, as you can see here, can have two possible oxidation states, +2 and +3. When I'm given this compound, how can we determine what the oxidation state of iron is? First, you're going to find the anion's oxidation state. In this case, it's always negative. Chlorine is, if it's negative, is always going to have a -1. If I set the sum of these together to 0, that will give me this charge of this. So chlorine has a -1 charge. I must take into account that there are 3 of them, so 3. If I add that to the oxidation state of my iron, which is unknown, and set that equal to 0, I can solve for x. So if I add 3 to both sides, I'll get x is equal to +3. Once I have the oxidation state of that cation, I can name the compound just like I did in Lesson 7, except I'm going to indicate the charge of the cation, that first element, with Roman numerals. So let's try some examples. FeCl2. So I'm going to look on my periodic table. For the second element, chlorine is only a -1 when it's negative. If I have 2 chlorines, I'm going to take -1 times 2 plus my iron charge, which is unknown, and set that equal to 0. So if I add +2 to both sides, I'm going to get x is equal to +2. Therefore, I know my iron's oxidation state is +2. Now to name this, I'm going to write iron, write the name. Oh, I'm sorry, that's not very clear. Erase that. Iron, the word iron. In parentheses, I'm going to write Roman numerals 2, chloride. For our second example here, we're going to start with finding the oxidation state of copper, because if you look here, you can see we have 2 possibilities. Fluorine, you're going to look on your reference table and find the negative charge. You'll see is always -1. So by our same thing, a -1 times 1, there's only one of them, plus my unknown x, copper. All those together, added together, will equal 0. So I'm going to add a +1, add a +1. Therefore, my copper's oxidation state is +1. So I'm going to write copper, the word copper. In parentheses, I'll put the Roman numeral 1 for its oxidation state of +1, and then write fluoride, ends in "ide." Let's try 2 more examples. I have Ni2O3. So as you can see, Ni here has 2 possible oxidation states, +2 and +3. Oxygen, if you look on the reference table, you will find that it has the oxidation state of -2. So now that I have 3 of them, a -2 times a 3, plus I have 2 nickels, my X, those added together will equal 0. So -6 plus 2x is equal to 0. Add 6 to both sides. 2x is equal to 0. Is equal to plus 6, excuse me. Divide by 2. I'm going to get x is equal to a positive 3. Therefore, I have identified this oxidation state as a plus 3. Now to write the name, nickel. One, two, three, in parentheses, oxide. Man, I keep jumping around. All right, another example, N2O3. So we know oxygen is a -2. If I take our same process, and oxygen is -2 times 3 plus 2 times x is equal to 0. I'll find, look, that's the same exact setup. Therefore, my x, I'm not going to go through the algebra, is equal to a plus 3. If we look on nitrogen, we can see there are so many different oxidation states. These are selected, but we do see plus 3 is here. Plus 3. Therefore, I'm going to write the name as nitrogen. I have to identify the oxidation state as a plus 3. Oxide. Let's try 2 more. Actually, you try these 2 examples on your own. I'll give the answers in class tomorrow. Writing the chemical formulas is actually much easier because they give you the oxidation state of that cation right there. So cobalt, you're going to have to look it up if you don't know the symbol, is a CO. We know that it's a positive 2. Chloride, you're going to look up the oxidation state as a -1. Now to write a formula, we're going to do our crisscross and reduce. Crisscross and reduce. That will get us cobalt chloride. So it's much easier going the other way. This chromium, this Roman numeral 3 refers to our chromium. So chromium has a plus 3 oxidation. Oxide, you'll look up, has a -2. We're going to drop the signs and crisscross, chromium 2, oxide 3. Finally, nitrogen 2 fluoride. This 2 refers to the nitrogen. N plus 2, fluoride -1. Drop the signs, crisscross, NF2. So check your understanding. And now you are able to identify binary compounds containing multiple charges by name using Roman numerals, and you are able to construct chemical formulas for binary compounds containing multiple charges.